Hello everyone. In this video, I will be explaining about why do we use state separation in rockets. I will be using spaceflight simulator mechanics in this for explaining this topic. Now let me explain what is this one-stage rocket and two-stage rocket. So, one-stage rocket means that there will be only a payload at the top and a fuel tank and a booster, and there will be no separations in between. So this one-stage rocket cannot do many mechanisms, and I'll tell you why later. In a two-stage rocket, there's a first stage, this stage, where there's a bigger fuel and a bigger nozzle for more propulsion, because at the ground level, let me put a graph here, and till here this first stage will be used. This first stage is used for the propulsion of the rocket and the payload above a certain height, so that the rocket, that is the second stage at the top, could easily propel the payload forward, like orbiting maneuvers. From here, the second rocket, this is the second stage, will make the orbiting maneuvers, which is for delivering the payload to a certain orbit, like a satellite, or for docking some supplies to the ISS. So this is how a two-stage rocket works. Now let me explain why does this one-stage rocket is not frequently used. As we saw in the two-stage rockets, there will be separators in between, and there will be a bigger fuel part in this area. This is the first stage, and the upper part there will be a second stage with the payload. So in this one-stage rockets, there will be the payload, which is P, and then here's the fuel tank F, and here's the nozzle N. These one-stage rockets are very simple and most often can be also called as missiles. Missiles are actually basically launched with a mechanism, and they shoot out with a payload, which is a warhead. So one-stage rockets are not meant to go to very high and long distances. Therefore, one-stage rockets are not mostly used for orbiting and all those things. So now think, why do we use these separations in rockets? Now let's see that this rocket has to go to orbit to just deliver a payload of a satellite. So we know that this fuel will not be enough. Let's say this fuel is not enough for the payload to get to orbit on Earth. Now what should we do? We just add more fuels and more boosters. If we actually do that, it may be successful. But what will happen here is that the mass of the rocket will also increase. Let's say the total mass of the first rocket, this piece alone was 100 tons. If it was 100 tons, and then one side booster, this booster, without any separation, let's say it is about 50 tons. So two of them would be another 100. So making the rocket's weight total mass 200 tons, say T tons. So the rocket's mass will also increase. And what will happen? As a lift off, we won't have enough fuel or enough thrust required. So what will happen is that, let me draw a graph for it. At lift off, the thrust will be given at the max. Even if it is given at the maximum, because of the mass increase, there will be the thrust could not compensate the mass. So let's see another scenario. Let's say the rocket has to go to moon, which is a really huge task, and the payload itself would be around 10 tons. So again, would we be able to add more and more side boosters, or just add them below and below? So that's a really very tough task. And if there are no separators, there is so much mass that the thrust from the ground won't be just enough to just propel the rocket forward. So only after time there is the empty of the first half tanks, the rocket would be able to propel, because the dry ratio means the mass of the container, that is the fuel container and nozzle, and wet ratio is the fuel and other components inside, like a payload. So if the wet ratio was totally around 10 tons, and then after the half that is empty, that is 5 tons of fuel got emptied, then only the rocket could get compensated for the weight or the mass, so that it will propel. So on the Earth, on the ground itself, at sea level itself, we'll be wasting half of our fuel. So now, Therefore, this is why we don't use these continuous stages. Instead, that we use the stage rockets. How do they work? There'll be a fuel here and a thruster, and there'll be a separator. The separator is very main. And why? Now, as I told you before, the thruster, if it's getting added and added, it'll be like a bunch and clumps. It'll be like going on like this. So, if you are having the separator, after a point, now let me draw a graph for that. At start, at the rocket at the sea level, would be having separators and it will not be that much big with a big row. Let's say the rocket is most probably like this. The nose cone at the top, payload, and then a booster, and then a separator, and again a fuel tank and a booster. Let's keep this simple. So the first stage, let's say the first stage gets cut off at this level. After this stage, let's say it traveled a distance at a time of this much, and after this area, after this place, the rocket doesn't have to carry this part. If the rocket doesn't have to carry this part, then the weight of the rocket will get decreased. So that after this place, the orbiting maneuver will be so much easier. This place, the orbiting maneuver. So what will happen to the separators? The rocket at the top would be having to carry with a very low thrust both the particles, which is very tough, and the orbiting wouldn't be succeeded. So there'll be this mass which is not even useful, useless mass here, which has nothing, no fuel and no things here. So there'll be a waste of mass, fuel and thrust. Therefore, there are separators with a small explosive charge, and the separator separates the waste, that is the useless, already emptied fuel tanks, from the usable or going to use fuel tanks and the payload. Now let me explain why do we use these staged by stage separations in rockets using spaceflight simulator. Now let me make a rocket without any stage separations, but really lot of fuel. I'm adding so much fuel tanks here. If I'm adding more and more fuel tanks and I need so much fuel to go to the moon, that is true, and I'm adding a single booster here. Let us see the scenario that what happens. You can see I'm switching on the engine, and then the fuel is just decreasing, but there is a lot of thrust produced at this point, but there is no increase in height. As I told you before, that only after the fuel decreases to half, the mass would compensate the rocket's thrust and the rocket could be able to fly. Till then, the rocket would not be able to fly. So now, let me build a rocket with stage separations. With the same rocket, could I move farther? The answer to the question is maybe yes. This is a separator. The separator is here and there's a separation. After that, I add another fuel tank with a more powerful booster. As I told you, this is a smaller fuel tank. Now, if you launch, then it will be just enough. The thrust is also very high, the velocity is increasing, height of the rocket is also increasing, and in the map, we can see that the apogee of the rocket is also increasing rapidly. So the height, apogee is around 4.5 kilometers, which is 5,000 meters. But the fuel of my rocket is also decreasing. You see 30, 29 and goes on like that. So after a point, the first stage, which is the fuel, is going to get emptied. As I told you in the graph before. So 18.4 apogee. Now here comes the part. Instead of carrying the whole rocket with this part, I'm going to carry, which has no fuel, I'm going to carry only this fuel part, which has 100%. So I separate this part, and this part just drifts away. Now you can see that after reaching the apogee, I'm going to turn on this small booster. Now, as I'm turning on this small booster, the apogee of the rocket, the height is increasing from 18 to 19, 19 to 20, which is in kilometers. And the fuel consumption is also low because I'm using a smaller booster. And how does the rocket get? As we get higher and higher out of the atmosphere, we can see that the speed needed for the rocket to move higher and further gets decreased. The velocity needed gets decreased because there is no more pressure acting upon the rocket while on the ground. As we go deeper between into the earth, the pressure increases. If you go farther away from it, the pressure decreases. So this is what is happening here. My fuel consumption is also low, and I can actually easily orbit the earth with this fuel. As you can see again, my approach is increasing 60 kilometers, and I can deliver my payload, which is just this rocket. I haven't specified any payload here, which can be delivered easily. So this is how basically this is why we use stage by stage separation rockets. This stage by stage separation rockets is really useful in the rocket science field. So now we can see that the rocket is nearly to make an approach of an orbit, which is not a perfectly circle orbit. It will be an elliptical orbit. But as the fuel here is again not just enough, we may actually make an orbit around the sun, which is highly unlikely. Now you can see that with this two-stage rocket, without that much fuel, without any controlling, we can actually circle the sun. Now I can see that the orbit, now after time wrapping, we can see that the rocket just escaped the Earth's sphere of influence and has started orbiting. So this is the use, and I just have a fuel remaining of 9%. With this we can save fuel and save mass and all those thrust factors. And I hope you enjoy the video. Thanks for watching.